Hello, everyone. And yeah, so I stand between you and your break. Apologize for that. I'll try to keep it short. So I want to talk today about what Hargrove and other companies are doing to help our clients and industry to improve their efficiency and their operations sustainability in today's environment using some of these AI tools here. So let's see. Bottom one, there we go. How about that one? That works better now. All right. So briefly a little bit about Hargrove. We've got 19 offices across North America, 2,700 teammates. We work in all range of industries. So we work for BSF and Alabama Power and a lot of other folks here, Bonic, other folks here in the crowd. And so we get to see a lot of different industries and work with a lot of different clients and really help them along with their digital transformation. A little bit about all the different things that we do and some of the other family of companies in Hargrove there. Again, they already introduced me a little bit, so I'll skip through that. I'll kind of get right to the topic today. So when we talk about improving sustainability, what are we really talking about? We are talking about how to be more efficient, use our resources better, use energy, use raw materials better, and to make a smaller footprint on the environment, right? And how do we do those things? There are some really big things we can do. And when I say big things, sometimes I mean there's some really expensive things we can do, right? We can totally redesign a process. We can decide, well, we're not going to make product A anymore. We're going to make product B anymore from now on. Those are all good things. A lot of times those are necessary things. A lot of times, though, what we can do is work with what we've got and become more efficient. So we can, if we're going to, burn natural gas to create electricity, can we burn it more efficiently? Can we extract it more efficiently? If we're going to make a chemical product, can we do it in a way that uses less energy? Can we increase our conversion so we have less waste? Those are the sorts of things that we can address with a lot of our digital solutions that are out there today. So that's what I'm going to talk about a little bit. I'm going to talk about some of the examples of categories of products that we can use, technologies we can use. I want to stop for a minute because a lot of folks, when we talk about Industry 4.0, and we just kind of jump in and talk about Industry 4.0, and we kind of have the assumption that everyone knows what we talk about and why we call it 4.0. And so I like to talk a little bit about the history of the Industrial Revolution. So Industry 4.0 was, the fourth Industrial Revolution, and it started with the first one back in the late 1700s. We introduced steam power and mechanization, interchangeable parts. If you read your history books, remember if you have children in school now, you talk about interchangeable parts. They talk about a lot of that came to the firearms industry first, right? You have interchangeable parts on your guns, and then it came to machines for spinning machines and making textiles. That's where it all kind of began. All right. Then in the late 1800s, we had electrification. Now all of a sudden, your mill didn't have to be next to the river, so they could be water powered. It didn't have to be powered by animals. Now you had electricity. You could put your factory anywhere you wanted. In the late 1900s, which we can call it now that we're in the 2020s, right? So in the late 1900s, we had electronics and automation. So we weren't just electrifying things. We put brains down into the machines, right? And so they could make pre-programmed decisions. And then now we've got the fourth industrial revolution, where we really have now artificial intelligence, hyperconnectivity, cloud computing, all these resources that are coming to bear, and it's really changing the game yet again. So when I talk about Industry 4.0, digitalization, smart manufacturing, factory of the future, all those terms, those are really umbrella terms for a lot of different technologies that can kind of get lumped in here. So I've show a little bit here about what some of those technologies are, some of the big players in that space. There are lots of players in this space, so a lot of small players out there offering really innovative products. Some of those players are, we're still in a young market for a lot of AI tools, right? So some of these small players they're going to grow and become big players. Some of these small players, they're going to get gobbled up by other big players, right? And then some of those small players are going to fade away. That's kind of the state of the industry, and that's okay. I don't want that to discourage people from going out and implementing solutions, because I tell people the thing about these technologies is that you can get real benefits from them today. So don't be afraid to move forward. Don't say, well, I'm going to wait until the market matures. I'm going to wait until. You're missing out on opportunities today if you wait now. The thing you implement today may not be the thing that you use 10, 20 years from now. That's okay. Most of us don't use WordPerfect anymore, right? That doesn't mean we shouldn't have ever used WordPerfect. It just means there's something better out there now, right? So not to pick on WordPerfect too much if you were a big fan of that. So some of the tools that we're working with today. AI, machine learning applications. There are a large variety of them, but there are a bunch of tools out there using what they call multivariate analysis. It's a little bit like you saw the neural network diagram before. There are other technologies underlying this, but basically there are a number of dedicated tools out there, like our first presenter was saying, weak AI, right? They're specialized. They only do a certain thing, but they are good at that thing, right? There are a lot of multivariate analysis tools that take in a bunch of variables, bunch of process parameters, bunch of data points, and then they'll run an analysis and give you some sort of output, some sort of recommendation, some sort of tweak to a set point, things like that, some sort of prediction about what is going to go on in your process, so you can kind of peek into the future. So there are tools out there that will help you determine, hey, that batch I'm working on now, how's that going to turn out? Am I on track to make a good batch? Am I going to make a good product? If you are, great. If you're not, if the AI is predicting that you're not going to make a good batch, do you have time to correct? Can you salvage this batch? Can you turn what would have been a bad batch into a good batch? That's increasing your sustainability, right? You're now not going to waste product. You're not going to have a product that you're either going to have to rework, a product that you're going to have to send to landfill, something that you're going to have to blend in with, some other good batches to still meet your quality targets, right? Those sort of tools will directly contribute to improve sustainability of your operations. So with these tools, you can determine, I'm on the track to make a bad batch, I can correct, or I'm on the track to make a bad batch, I might as well stop processing it now, go ahead and dump it, start again, fix whatever issue caused it, right? Maybe it alerts me I've got a bad batch, and you stop and think, well, why am I? Oh, okay. Well, my pressure sensor's clogged. I'm not reading the right pressure. I need to address my instrument issue before I go back and try another batch, right? So you can do all those things, save you time, save you money. All right. I like to talk about APC. For those of you who are not familiar with the industrial world, APC stands for Advanced Process Control, and it's a little bit funny. We include it as part of our digitalization offerings at Hargrove. APC has actually been around for 30 plus years. It actually far predates the term digitalization and all this Industry 4.0 stuff. And what it is, Advanced Process Control is an alternative control methodology to standard what they call PID control. That's PID control is what controls 95% of process control loops out there in industry. And so, normally it does a pretty good job of doing control, but for certain applications, certain process dynamics, it only kind of works so. It's only limited. It is limited in the fact that it's only really looking at one variable. You can do some cascaded controls, but that's then you're stacking PID on top of PID control. But a single PID loop looks at one process variable, and then just either looks at a control valve or a variable speed drive and gives you a little more or a little less, a little more or a little less, depending on what that one variable it's looking at is doing. APC looks at multiple process variables to create a better model of your process dynamics. And the idea then, hopefully, is that instead of having this much process dynamic behavior, that you can get that down to a smaller range. You can get tighter control. And once you have tighter control, now you can kind of tweak your set points up or down a little bit toward some operating limit so that you can have increased efficiency, that you can have increased conversion, you do all those things. Again, that goes directly toward improving the sustainability of your operations, making your operations more efficient. Even though APC has been around for a long time, it's really not widely adopted across industry. It's widely adopted in refineries. It's widely adopted in certain large-scale bulk chemical continuous processes, but there are a lot of folks out there that have not implemented APC, either because in the past it was too scary, too expensive, too cost prohibitive. Those numbers have changed over the years. APC and some of the kind of junior APC tools that often come built into your basic process control systems now, they're more accessible, they're cheaper to use, they're easier to use, they're easier to maintain. People really should be looking more at APC tools in their processes. I want to talk a little bit about RAM modeling. That's another tool that we work with pretty often at Hargrove for our clients. RAM modeling is reliability, availability, maintainability. And what it's doing is it's looking at a statistical analysis of kind of your predicted OEE, your overall equipment efficiency. And so what it's doing at the design phase of a process, you're looking at what pieces of a process do I think are going to most contribute to my uptime or downtime. All right, and if I look at, okay, this tank here is a pinch point in my design, that's going to be a contributing factor for most of my downtime. I can say, okay, you know what, I need a slightly bigger buffer tank here, or maybe I need 2 buffer tanks, or you can start to play with different scenarios at the design phase. So because the best way to have a sustainable process is to design it right from the first place, right? Don't just take what you've got and try to work with it, but try to design it better in the first place. All right? But once you have a process, the other things we can look at, okay, this is my process. Can I do a debottlenecking project? Can I do something here to just slightly tweak what I've got? All right. What other options do I have? Can I look at my spare strategy, my maintenance strategy, my operations strategy, given what equipment I have, what can I do to operate things differently to improve my uptime? And when I talk about uptime, how does uptime, again, relate to sustainability? If I have an idle process, if I have a process that's down, typically that doesn't mean that process is totally shut down and not using electricity, not using natural gas, not using other utilities. I'm typically keeping certain components hot. I'm keeping certain components under pressure, under vacuum, whatever. I'm still running a lot of motors. I'm still doing a lot of things. Even if that process is not making pounds for me at this given moment, I'm still spending money, spending energy on keeping that process in a semi-idle state. So again, that's affecting our sustainability. If we can improve our overall uptime, then we're going to improve our sustainability. The other thing here too, of course, is if I have shutdowns, if I have downtime, often that means that I'm having cleanouts, I'm having waste material being generated, all sorts of things like that. Another big one here, when we talk about multivariate analysis, I talked a little bit about predicting whether a batch was going to kind of go awry. The other thing that we can do with these AI tools is predict when I'm going to have equipment failures. So typically, if I'm just looking at a sensor in my control system, a vibration, a temperature, something like that, I'm going to get very short notice I'm going to have a failure. Usually minutes, and at that point it's often already detected, mechanical damage, and maybe I'm going to have some upstream, downstream propagations from that damage, right? If I use a multivariate analysis tool, I'm now going to look at a lot of different sensors to find that fingerprint of when I'm going to have a failure, and when I do that, I get much earlier notification that I'm going to have a problem, and by doing that, I'm going to avoid major equipment damage, and I'm going to be able to plan my outage, plan my turnaround, and that's going to reduce my turnaround times because I'll be able to plan. I'll have my crew ready. I'll have all my parts ready by the time I shut down. So briefly before I end here, what are the keys to success in the digitalization space? So number one, start small, because we want to get something that we can basically easily get funded, right? But we want to make sure that we don't start too small, because we need to actually demonstrate at the end of the pilot project that this project was successful, right? So you want to make sure that you pick a scope, a duration, a breadth of scope that you're going to be able to demonstrate really positive results, clear results. You don't want to have anyone question you after the fact. Well, but could that improvement have really been due to this other thing? You need to make sure that you've kind of sized your pilot right. All right. Number two here, you got to involve the right stakeholders. Make sure you understand that when you do something like this, you're asking people to change, and we had that come up in an earlier discussion as well, right? People will be impacted. Some people will need to change their work processes just to support what you're trying to do. Other people will be affected by that, outcome from that digitalization project or whatever you have. So you need to understand the impact that you're going to make on people, and make sure that people have buy-in, that they're good with it, they're going to support you long term. Have a scale-up plan. So if your pilot goes well, have that plan for what's the next step, and then don't leave the project execution up to a single champion. I've seen that happen many times. Things go really well while that champion is active and involved, but then that champion gets a new assignment, moves to a different role, moves to a different company, and there's not a legacy left behind to really continue that project going forward. So make sure you have that long-term support plan in place. And that may mean that you need continued outside support to help feed and maintain this new application you've got, and that's okay. So, any questions?
I got one. So
certainly.
If you had a process that had, say a dozen different variables, but you don't know, to your point earlier, how to optimize the process because there's so many variables.
Right.
Do you guys have a tool that you can, if you've got all that historical data and you know what the ideal outcome is,
right,
but you don't know what parameters ought to be changing, is there something you guys can feed that into that will?
So most of the tools, well, I'll say number one, nothing replaces human intelligence, right? All these artificial intelligence tools are designed to supplement human intelligence. So it still pays to have good engineers with process know-how and understanding. These tools, most of them don't understand the process. They're making these statistical inferences, these correlations, but they don't understand the engineering principles behind. There are some physics-based first principles tools out there, but relatively few. So have a good engineer that can kind of, pre-screen what data you think is going to be important. Make sure that data is clean. If you've got noisy garbage data going in, it's going to, make your model go south. But as you feed that data in to these learning algorithms, they'll kind of point out to you, generally speaking, okay, here's my predictions, and of the parameters you fed me, these were the ones that ranked as important. And then you can go through and you can further refine. Okay, well, I fed you 20 data points. When you developed your models, you said only the first, these 10 were really important to the model. Okay, I'm going to pull those 10 out, and I'm going to retrain now, and I'm going to now give you a prediction, and I'll compare. Is the prediction now as good or better or worse once I kind of culled some of the extraneous info out? So, other questions?
Any other questions? Thank you
All right.
so much, Heath.
Thank you.